Hi, Jude. How are you?
I'm fine, Tev. How are you doing?
I'm great. I'm so excited for this interview. I mean, I've been absorbing so much of your information over the this past few days and this last week. It's been amazing. How's
Oh,
it on your side?
yeah, no, it's great here. I'm enjoying the summer. I'm sort of getting to a point now with the end of this month. It's been so full on that
Mm.
I'm really looking forward to taking an in breath, hopefully for a couple of months, which means I there's a lot I'm feeling coming in. So I really want to be open and have the space to really, appreciate that and try and sort of have a sense of what it is all about.
I mean, I can imagine your work is absolutely fascinating. There's so many different topics we could discuss today. I can only imagine the inundated emails you're probably receiving from so many people who are keen to hear about your work.
Bless you. Well, it's very busy in a really good way because I do feel that with so much flowing that now is the time, and people are really needing to have some hope that's authentic, to have some sense of an underpinning and a framing to a sort of a healed worldview. Not a fragmented perspective based on the old paradigm, but the evidence-based authenticity of something that can really, empower us to come together, and because that's the time, isn't it?
And no, no, for sure. I mean, I'm great. I'm grateful that you've started already because I mean, I love to just get started. And at this point, I think the question I want to ask you, you talk about this cosmic hologram, Jude, and
Mhm.
governed by information. I think let's explore this idea. I mean, it's been around for many years. It's been around for decades, millennia, in fact. But only now do we see a growing body of evidence that supports this idea. And I think it would be amazing for the listeners and viewers to listen to this evidence and for you to express yourself in a nice open platform where the listeners and viewers can appreciate it. And just by the way, Jude, the audience are generally very technical for this podcast, so go into as much detail as you want. Don't shy away from the physics. Yeah, just I'm curious this cosmic hologram and everything about it. I'm looking forward to this.
Okay. Well, there's probably a couple of convergent points to be making here, but let's talk about the holographic principle to start with,
Mm.
because that really, as you say, it's been around for a while now, and the sort of very early intimations of it really date back to David Bohm.
Mm.
So we're talking about 4, if not 5 decades as a sense of what this might mean. But of course, the big move forward came when researchers were looking into the thermodynamics of black holes. And people like Gerard 't Hooft and Leonard Susskind and Jacob Bekenstein and others. And the question really was, what happens to the information that's actually, making up a massive star when at the end of its life, its nuclear fuel runs out and it collapses. And of course, the collapse is so gravitationally powerful that it actually collapses within an event horizon, and therefore not even light can escape. I know there's a nuance with that with Stephen Hawking's work, but essentially, not even light can escape. And so at the event horizon, you suddenly get this blackness that we term a black hole. And of course, as the star collapses, a spherical star collapses as a spherical black hole.
Mhm.
So the idea was, well, first of all, is the information lost? Because if it was lost, that would blow quantum physics out the water, literally. So there's a huge debate about firewalling and what's happening all of that. But as time has moved on, that has more and more evidence has suggested that actually no, the information is
Mhm.
actually held at the event horizon. But then the big question was, well, what is that information? And when calculations were done that related it to the thermodynamics of the black hole, it was realized that the information was proportional not to the spherical volume of the black hole, but the surface area of the event horizon. And then a few light bulbs went off. Because that is very, reflective of what happens when on Earth we technologically create a hologram. Take a beam of light, we split it in two. Part of the beam is focused on an object. It's bounced off the object and it collects information in that reflected light from the object. It then combines with the initial beam to form a two-dimensional pattern of information that actually looks like an oil slick. If you actually look at one at that point in its process, it looks like an oil slick. But it's basically a wonderful ability of our universe to be able to transform information into waveforms and waveforms into information through Fourier transforms. And this is absolutely critical, not just to our human-made technological holograms, but also how the holographic principle works at the universal level, which we can come on to. But so essentially, there was a realization you've got this two-dimensional informational pattern, and when you throw another beam of light through it, it projects what we call a hologram. And the point of the hologram that it projects is that the whole is in every pixelation. So if we have a high definition pixelation, then we, all the wholeness, if it's an apple, for example, you get minuscule apples throughout the whole hologram. But taking this now to our universe, it was realized that from black holes, we could extend this, what became known as the holographic principle, to the whole universe. And we could go back into the evidence for this because there is compelling evidence now at all scales of existence and many different fields of research. But the sense is that the appearance of our universe, the energy, matter, and space-time appearance of our universe is not its more fundamental nature, but the appearance arises from this deeper realm of causation as meaningful information. And I always hyphenize information to sort of really emphasize its meaningful nature. But that meaningful information is actually accumulated on the boundary of what we call space-time, and then holographically manifested as the appearance of our universe. So if we go back 13.8 billion years to the very first moment of space-time, not in a Big Bang. We know it wasn't big. I mean, that was Fred Hoyle being very facetious. But, the implication of a bang, it wasn't. It was incredibly fine-tuned and ordered. It began in its lowest informational state. So as time has flowed forward ever since, because of that entropic flow, began in its lowest informational state. As time has flowed forward and space has expanded, that holographic principle, allied to other laws of physics that we can come on to, has meant that our universe has been able to undertake this evolutionary arc from simplicity to ever greater levels of complexity, experience, evolutionary potential, individuation, self-awareness at those levels. That's the story of our universe, because that first moment, not of a Big Bang, but the first moment of a big breath, an ongoing big breath. And the reason that space has to expand is because that is where the accumulation of the emergent evolutionary information is held. So if space didn't expand, there could not be more and more and more and more information able to be expressed in its evolutionary arc. And of course, what happens is the pixelation of the holographic boundary of our universe, as Jacob Bekenstein understood, is pixelated at Planck scale. So in that sense, our universe is the reality of our universe comes into form at the Planck scale, which is a basic measures of space and time and energy, matter as a result, and temperature. And so it all hangs together, but that pixelation scale, that Planck scale pixelation at a spatial level, is as small as to a nucleus of a hydrogen atom, as a hydrogen nucleus is to the whole universe. It's 10 to the minus 35 meters. It's trillions of times more minute than our best high definition human holograms. And the point is that is the way that what we call the boundary of what we call space, the holographic boundary, is able to encode more and more cosmic and universal information. But the point is also that the flow of time itself at every Planck scale temporal pixelation, which is 10 to the minus 44 seconds, get your head around that.
Numbers.
It's like every Planck scale time is like adding another another movement of the whole universe's emergence. Of course, it is so minute that it's rather like us watching a television screen. The pixelation is small to us, so we see the whole image. We don't see the pixels. Well, this is the pixelation of our universe's reality. So that's a start anyway.
I mean, it's a brilliant start, and I love the way you articulate this, because it makes it a lot easier for people to understand. When you're talking about the fact that it's obviously expanding in the terms of the way that we used to express it, but now you're talking about it as information rather than matter in the same way we usually discuss it. I've seen a lot of people sort of mistake that for new content arising, whereas we know that, well, according to the laws of thermodynamics, matter is neither created nor destroyed. So you talk about entropy rather than entropy. And I do.
And as a child, this is really sad. When I was about 7 or 8 years old, I was always asking, why at the time it was mainly 2 laws of thermodynamics, but there's a third law which is relating to a closed system, where the temperature of a closed system is inversely proportional to its entropy. So my question for a long time was, why are there 2 laws of thermodynamics? Because I'm a great follower of one of my great heroes, Albert Einstein. And to paraphrase Einstein, the universe is simple as it can be, but no simpler. And I add, to fulfill its evolutionary purpose. And that add-on is really key, because what I realized when I was writing the cosmic hologram, and also more latterly the story of Gaia, is we can actually restate those 3 laws of thermodynamics to what I call 3 laws of infodynamics. So the first law, if we go back to the initial first law of thermodynamics, began, of course, essentially with Boltzmann, saying, as you say, the energy of a closed system cannot be destroyed or created. It can change through time, but it cannot be created or destroyed. So if we take the science going further than Boltzmann, and bless him, I mean, Boltzmann was doing his work before even atoms had been validated. So he was an amazing, again, pioneer and great giant, for which I feel we should all be very, very grateful. But taking that on, we now know that energy and matter are equivalent, E = mc squared. So that says that the energy matter of a closed system cannot be created or destroyed, just change through time. We also, for our laws of physics to work at all, and this is something that really still some folks struggle with, but all the evidence is really showing us that our entire universe is I call containered system, because closed system has a very specific topological perspective and it can be confusing. So as a containered system with this sort of holographic perspective, it means that the energy matter of our universe, from its first moment to its last, and there is also now more and more evidence that it's a finite life cycle, can neither be created nor destroyed. It can change. Now, that essentially is the first law of thermodynamics applied to our universe. But when we also appreciate that in 2012 and since, there have been experiments that have shown that information is every bit as real as any thermodynamic measurement, so work, heat, etc. So we also now know that we can start to expand that first law of thermodynamics to a first law of infodynamics, where information expressed as quantized energy matter can neither be destroyed or created, but just change through the cycle of our universe. Now, that's fine, because that, in its essence, which is quantum physics, because, of course, energy matter is the domain of quantum physics in description terms, that's all great, but it has no notion of space or time. It's the seed, it's the framing for how our universe can exist. But this, then, the second law begins to answer my 7-year-old's question: why do you need more than one law of thermodynamics? Because the second law, which you say quite rightly, is about originally the notion of entropy. So the idea is that the entropy of a closed, I'm going to say contained now just for consistency, a contained system it has to increase over time. And there's been a lot of misunderstanding about this, because a lot of folks think of entropy as order to disorder. But what Boltzmann was really talking about was the energetic microstates of such a system. And when you think about it, I sometimes use an analogy of a pack of cards. If you take a pack of cards out of its sort of box, they're very ordered, yeah? You throw them up in the air and they land all over the place, and you put them together and they're not in that initial order. But rather than order to disorder, you're just increasing the number of states through time. So every time you throw them up and they land, more and more states are formed. So it's this progress through time of increasing micro energetic states. But of course, we now also know that we can see information, and again, we can go into a lot more detail of the evidence for this, as also being expressed not just as energy matter in its quantized form, but in a complementary way as space-time. That's where the holographic perspective comes in. So that second law then, when applied to our universe, can be restated and in informational terms, that first of all, the entropy, because I'm now talking about information, whereas entropy is about energetic microstates, I move from entropy to intropy. It just makes it easier. But the equation that describes the informational content of a contained system and the entropy, the energetic microstates of a contained system, is the same equation.
Yes.
Originally defined by Boltzmann. So we're onto something here. And so now if we look at the second law of infodynamics, it says that and of course, let me go back to the first law for a second, because I want to bring in space and time here, because this is vital. So the second law of thermodynamics says that the entropy of a contained system can only increase through time. Okay. And we're talking about contained system here. So now we move into 20th century physics, and we now know the equivalence of space and time. So relative space and relative time, lovely that they are, have to be conjoined as invariant space-time if we're going to have a universe that hangs together. Yeah. And we can actually talk about a universe that hangs together and the laws of physics and all the rest of it. So we can then expand that second law of thermodynamics from the entropy of a contained system only increasing through space-time to the entropy of a contained system as its information content only increasing, in our universe's case, through space-time. So literally, as space expands and time moves forward, the information content gets bigger and bigger and bigger, and that's the entropy. Okay. Third law this is cool. I love this, because this really came to me quite late on, because I was thinking, gosh, why is there a third law? Where does temperature come into this? But the third law of thermodynamics, as I mentioned, says that the temperature of a contained system and its entropy, now entropy, are inversely proportionate. So we now know that our universe began in its highest temperature form at the Planck temperature, 10 to the 32 degrees Kelvin, and its lowest entropy. So as time flowed and space has expanded, the temperature has dropped. That drop in temperature is allied inversely to the increase in informational content, entropy. It is so simple, Tev. I mean, it all hangs together in this glorious way. And then the final cherry on top of it is essentially that I talk about meaningful information. Yeah. So the wholeness of our universe as meaningfully informed and holographically manifested, its framing can be done. It can be brought together with these three laws of infodynamics. The first law is the most simple statement of quantum physics. The second is the simplest form of relativity physics. But together they combine within these three laws of infodynamics, which with a hyphen are three laws that bring together our universe that meaningfully exists and purposefully evolves.
I think, I mean, it's incredible because this is what we've been searching for such a long time. People have been looking for a unifying theory of this universe. I mean, it's been the goal. When you think about Stephen Hawking, and I know you guys, when you were the youngest participant and you won the award, I can't remember exactly where, but you obviously met Stephen Hawking at that time, many years ago. How old were you? 19 at the time?
I was 19, and my mentor was Dennis Sharma, who was Stephen's doctoral supervisor when they were at Cambridge. And then Dennis came over to Oxford, and I was doing my physics at Oxford. And Dennis, bless him, he just took me under his wing. And after Stephen and Roger Penrose, who got the Nobel a couple of years ago, came together to present to the postgraduate department, and Dennis invited me along, even though I was an undergraduate. I was the youngest person in the room. I think I was the only woman in the room. And then afterwards, Dennis said, why? Because it was all black holes. They were like, woof, this is coming forward. And Dennis said, why don't you enter this essay competition? And I said, sure. And he said, why don't you write about black holes? And I went, sure. So I did, and I won the prize.
Was it 25 quid?
It was 25 quid. In those days, this was the early 70s, that was beer money for a term.
The reason why I bring that up is, Jude, I mean, of course, we think of Stephen Hawking, we think of theories of everything. I mean, there's unification of quantum mechanics and space-time general relativity. How do we combine these concepts? But also, when you think of Stephen Hawking, you think of black holes, event horizons.
I know, it's come forward. It's come full circle. It's quite extraordinary.
And I want to go into that. I mean, unless you want to address the evidence first, how would you like to approach it? Would you like to go into black holes now, or first talk about the holographic principle and how we've gathered more evidence over time and certain experiments that have helped to solidify this?
Yeah, I'd be happy to. And I think the other thing that's really key in all of this is that our universe exists and evolves in this way, meaningfully exists, purposefully evolves, manifested holographically and meaningful information. But the other key aspect of it is our universe does so as a non-locally unified entity. And this, of course, if we can take a couple of minutes just to nail this one down, I think. This was something that came out right in the early days of quantum physics. And many of the quantum physicists were, of course, scientist mystics, and some of them went to India and started really appreciating the Vedic tradition of ancient India, the rishis, the Bhagavad Gitas, the Upanishads, were basically telling the same story, that they were realizing. And what became clear is that for quantum physics, quantum mechanics to work at all, essentially our universe had to be non-locally unified in its entirety. And of course, Bell came out with his, sometimes called a theory, sometimes called an inequality, but nonetheless, it was a test bed for this. And at the time, it was a theoretical perspective. And it was only many, many decades afterwards, we're talking 70s, 80s onwards, that researchers were able to start to experimentally test this at greater than quantum scales, because it was clear it was happening at a quantum scale, but was it able to be expanded to a universal level? So you had researchers coming along and progressively increasing the scale well beyond any quantum levels to show entanglement. And in 2017 and then 2018, a group of, I think it might have been 4 or 5 universities, one of which I think the lead was MIT. And what they were able to do was non-locally entangle photons of light in their laboratory with starlight from 600 light years away, but also triggered by light from a quasar, a very active galactic center. 2 quasars, actually. One, I think, was 7.8 billion. The other was 12.2 billion light years away. And that was a triggering that actually created a level of entanglement that exceeded the inequality test, the thresholds of Bell. But beyond that, in late last year, the Nobel Prize for Physics were given to 3 researchers who've been working on this for decades. Anton Zeilinger, who was also part of that MIT collaboration, Alan Aspect and John Clauser. And the Nobel Prize is only given for settled physics. I often say Einstein didn't get it for relativity because it was seen as being quite contentious. He got it for the photoelectric effect. So the fact that we have now the Nobel, we've got this experimentation at cosmological scales. We have all of the theoretical framing now to support this, and the evidence across many fields of research that also play into this. It's an amazing and exciting time, not just for scientists, because as we'll go on, I'm sure, to explore, this is important, this is vital for everyone.
A lot of implications. There's so many practical implications.
Everything.
Exactly. I mean, when you think about it, as you said, Nobel Prizes are only given to settled science. And I mean, he got it for the photoelectric effect. He didn't get it for what he's best known for. And that's pretty incredible, because at the time, of course, I mean, he called it spooky action at a distance. And we know that he wasn't comfortable with this concept. I mean,
he would have been now, because I'm convinced he would have been now, because of course, he and the quantum physicists were working decades before the neutron was discovered. I mean, let alone the hologram, let alone the cosmological understanding we have, let alone, the sort of leaps and bounds we've had to understand the significance, the fundamental significance of information and meaningful information, which means, of course, the slippery slope, yes, please, of consciousness.
Yes.
We have to bring this front and center. Of course, what he did feel very uncomfortable about, as did Planck and others, is that whereas quantum physics and what they're all coming to really gave us the clues that mind and consciousness aren't something we have. They're literally what we in the whole world are. That was literally pushed to the side. And so it's taken almost another century and an ability with the old framing to reconcile quantum physics and relativity physics, because they're at the appearance level of our universe, of energy, matter, space, time. We've needed to understand this deeper level of causation, which is meaningfully informationally driven, and then being able to show how information expresses itself in these complementary ways as the appearance of energy, matter, quantized energy, matter, and entropic space, time, brought in the holographic principle. I think he'd be jumping up and down and going, yay, because he was one of the folks who was saying, mind and consciousness are what we are, what the whole world is.
I mean, so Jude, I mean, for the listeners and the viewers, I mean, I was introduced to your work by Don Hoffman, and
Yes.
and he told me it would be a very fascinating conversation, and it clearly already is. But I remember when Don and I were talking about it, he was telling me about your work, and I found it very intriguing, because, I mean, Don has such amazing work being done. They're currently doing the new test to experiment whether physics arises from consciousness, and I think they just released it yesterday. I think it was, 26th of June. So
Yes.
When you talk about consciousness from an idealism perspective, because this is fundamentally what the view entails from a philosophical perspective, it's an idealist view of consciousness. Consciousness is what we are and everything that there is, technically, in a sense. How do you work around this concept of consciousness? How do you define it? How do you explain it to people? Because obviously this podcast is called Mind Body Mind Body Solution for a reason.
Absolutely. Well, the very terminology, what's consciousness, you'll get 5 answers from 4 people. And I have a very broad church of consciousness. And, a friend of mine, Professor Max Velmans, differentiates mind and consciousness and talks about consciousness as a level of awareness, whereas mind is fundamental. We can talk about mind as being cosmic mind, as Einstein would have called it, the ground of all being, and so in that regard, our universe is mindful. And, the way I'm working with this, and my next book will dive deeper into the ground of all being and the rest of it. But both for the cosmic hologram and for the story of Gaia, I really wanted to show how what I would also refer to as cosmic mind, an eternal and infinite mind, has thoughts that, we term our universe, which is very much, pervading universal wisdom teachings. And in my own explorations, as a noetic experiencer all my life is very much the way I've experienced realities. But by being able to articulate it is as cosmic consciousness, cosmic mind, expressing itself as the appearance of our universe through the articulation of digitized, meaningful information. I mean, we're almost predisposed to this now because our communications technologies, take the image of me, gather all the information, the meaningful information about me, translate it into digitized ones and zeros, squirt it down a cable off a satellite to your computer, recombine it as an image, does the same vice versa. This goes back to the incredible attributes of Fourier transforms, the way our universe can, make this beautiful play of information, waveforms. It all hangs together, but it hangs together with the evidence showing that it has innate meaning. This is the key, I think. This is not random data, just as our conversation. Well, I don't know. Some people may say it's random data, but hopefully our conversation is meaningful. But of course, the meaningful nature of our universe is not dependent in any way on human sentience. Yes. It's a universe that is itself living in that sense, mindful, informational, where everything in it, from atoms and molecules to planets and plants and people, have a part of that meaning, an essential purpose. So it's a broad church, but it's innately the same fundamental stuff, the nature of reality.
Jude, what are your thoughts on Don's work?
When I first, it was so lovely because Don and I met at the Science and Non-Duality conference in California before the pandemic, and had lunch together and really enjoyed being together, and have had a number of conversations since. And I love his work. I'm coming from this primarily as a cosmologist and as an evolutionary biologist and a systems person, and you could argue a philosopher, but many, many different hats. And because I'm so curious, I like to join the dots and see where they lead. Don comes from it more from human consciousness.
Yes.
And how our human consciousness relates to this wider consciousness. And his book is very provocative because, of course, from the human consciousness perspective, our senses are not direct in direct touch points with universal consciousness. We moderate, we mitigate,
exactly.
Our sense of self through a number of ways of forming meaning. But when we met, I realized that he wasn't in any way decrying or not acknowledging universal reality. He was only really exploring the ways in which we relate to that larger understanding of reality. So, as microcosmic co-creators, as I call us, of our universal living intelligence, he and I are very close. So, we agree very much. What I really love as well is he's working with a number of quantum physicists in a sort of more specified way of how this works. But what I would say is the work that I've done offers us the underpinning and framing through these three laws of infodynamics. And I'm happy to sort of say to Don and the other guys, I'm really excited about what you're going to come forward in this, because it's going to come, I just feel it's all convergent. It's all the same direction of travel.
I'm glad you brought up a quantum physicist, because I mean, another theory of consciousness that circulates is that of Penrose. When you think of Stuart Hamerhoff and Penrose, they talk about quantum consciousness and the microtubules of cells. Your thoughts on that?
Well, I write about this a little bit I write about quantum biology in the story of Gaia, because whereas the cosmic hologram was bringing the evidence and this underpinning and framing of these laws of infodynamics and the cosmology and all the rest of it, that was back in 2017. In last year, with the story of Gaia, I wanted to tell the evolutionary story, not just of our planetary home, but our entire universe, because the story of our universe as my friend Brian Schwim and I both talk about, is a story of us. You know, the hydrogen in our bodies is as old as the universe. We're not just stardust, even though we are. Okay. We go back, way back.
We're all 13.8 billion light
years.
We're
all 13.8 billion years old. So in that sense, the evolutionary story is extraordinary. And what you see throughout it, and really came to me ever more strongly as I wrote the book, or the book wrote me, I feel, is a sense of evolutionary purpose. Because what you have, you know, all the way through is this almost preparatory processes, that things were in place that could then be assembled when the conditions were right. You know, if we go back before our planetary home came into being about 5 billion years ago, around 5.5 billion years ago, the harbingers and the nutrients that would create our sun and our planetary system were all there gestating in interstellar clouds of gas and dust, including complex molecules. And we start to get the sense of that quantized nature of potential playing out there, where even within those complex molecules, we were starting to get enzymes coming into being. And enzymes, you know, are vital to the speed in which proteins come together and build biological organisms, because the enzymes speed those processes up dramatically without in themselves changing. And the view very much is that involves quantum tunneling. Mm-hmm. And so when Stuart and Roger have been bringing these ideas of microtubules forward, I don't think it's the most fundamental aspect of how this is playing out, but I think it's an important contribution to the conversation. And other people such as Jim Al-Khalili has also written on quantum biology. You know, there's a view that some of them have expressed that photosynthesis is quantized in nature. I personally haven't seen the evidence that's convinced me of that. I think there are other processes that are at play that don't actually need that aspect. But there are others where, as I say, enzymatic action and others, there are other ways in which the DNA double helix is formed and molecules such as Posner molecules and the way that works that can really hold memory for a very long time, likely because of quantum resonance. Mm-hmm. Yes, I write about all of this in the story of Gaia because it's very important, and it's very much an emergent field of study.
Yeah, no. So I'll definitely be putting links to your books below and to the website, of course. Where when I remember while reading, I was thinking to myself, there were two specific experiments I wanted to ask you about while reading. It came to my mind immediately, and I thought of the observer effect and the double slit experiment. Yeah. And I wanted to just know your general thoughts on that. So I have one more question, but I think before I get to the second one, just what are your general views on that? Because when I interviewed Don, I remember talking about when we talk about consciousness being fundamental and the entirety of our reality. And I labeled the podcast a new experiment to test whether consciousness, whether physics arises from consciousness. And someone commented saying, have you ever heard of the observer effect, as a joke? So I think with you, let's address that, how that supports this idea, how infodynamics.
I really want to, though, expand this perception that the universe is the universe, whether we're here or not.
Yes.
Yes, I think that's really important because so much perspectives about consciousness is human-centered. Yeah. And I'm not suggesting that's problematic. I'm saying it's both and.
Yes.
And the way that we as microcosms of our universe as macrocosmic consciousness, sentience, livingness, mind, because I think we can get caught up in the languaging a little bit. And I want to sort of get a more sort of generic sense of this. But yes, so going back to... Remind me, I think I'm losing the thread here.
So when
observer effect. Yeah, okay. That the point is we're embedded within a conscious universe. Mm-hmm. There cannot not be an observer effect because we're both observer and observed. Mm. We are naturally embodied. We're inseparable. Mm. We are literally inseparable. But I think the important point there is that the unity and unified nature of non-locally unified nature of our universe has two aspects. First of all, it means that although our universe exists and evolves as a non-locally unified entity within space-time, light is the cosmic speed cop. Signals cannot go faster than the speed of light within space-time, which means that we can have this journey of 13.8 billion years. We can have a flow of time. We can have a causality. And this is important when we start to explore supernormal phenomena. Because although this both and enables naturalizes supernormal phenomena, naturalizes our intuitive insights, naturalizes synchronicities, it's a both and. So there is this causality playing through. So, I was in a panel with Dean Radin and the IONS folks a couple of days ago, and Don was being given a prize there, which is wonderful for his work. But essentially, because it's a both and, we are both observer and observed. We are inseparable, but that unity is differentiated. It's unity in diversity. It's in radical diversity. So yes, we're informational beings within an informational universe. Whether we know it or not, we're in continuous dialogue, multilog. Yes, with all around us. We are, we talk at WholeWorld-View of act local, feel global, think cosmic, because we are all, and we are uniquely, our universe is breathing through us, each of us uniquely.
So let's apply this law of infodynamics. Let's apply infodynamics to different systems so people can get a better understanding or a better picture of this. So let's think of it from, maybe let's take into account a biological scale, or something like DNA, then apply it to something like human civilization, take it to economics, and then we continue from there. Just maybe start off from an atomic scale, perhaps, and then let's work our way up.
Okay, let's do that, because what we're finding is that the informational patterns, the relational, dynamic informational patterns, many of whom we call fractals. Not all the relationships are fractal per se. We have other relationships that we can come to, for example, power laws, but we find the fractal relationships which are essentially geometric. When Bekenstein was doing the holographic work on information and the pixelation at the boundary of what we call space-time, that Planck scale pixelation on that two-dimensional boundary of space-time is triangular, okay? Because then it can tile without a break. It's the ideal geometry that doesn't overlap. So within each Planck scale, pixelation, there is essentially one bit of information, and it's at such a minute level that when we scale it up to atoms or quarks or neutrinos and beyond, it has a lot of information already at that accumulated scale. But what we find is that, for example, when an element is going through a phase transition, for example, between an insulator and a metal, its electrons cluster fractally. So from that scale, we start into, because of course the Planck scale is much tinier, that pixelation scale is much tinier. So we're at atomic scale. We also find fractals running through from that scale upwards. So for example, on a planetary scale, clouds are fractal in that sense. Weather patterns are fractally based. River systems are fractal. But the key thing here, and let me just go up to cosmic scale, and then I want to come back because there's a key point here. We find that at a planetary scale, but also when we look at a solar system scale, the solar wind is fractal. Some of the ways in which the resonances of planetary orbits and the planetary system as a whole have fractal relationships. We go into the galaxy, we see fractal patterns here. We go to cluster of galaxies, we see fractal patterns. And in 2017, Afshordi and Skanderis and a group of folks looked at the cosmic microwave background, which is, as you know, is the relic radiation left over from what's often called the recombination era, around 380,000 years after the beginning of the Big Breath, where space had expanded enough and temperature cooled down enough to become transparent, because before that, space was transparent to acoustic signaling, but not to light. When that happened, again, there was like a phase transition where space became transparent, and therefore there was a relic radiation that filled the whole of space at that time. And because of the temperature that was in play at that time, we think that it would have had an orange glow, which I quite like the idea of, really. Anyway, that filled the whole of space. As space has continued to expand ever since, those wavelengths have sort of lengthened to microwaves now. And so we call it the cosmic microwave background, and it fills the whole of space. In 2017, an analysis from the WMAP, the Wilkinson Microwave Anisotropy Probe map, was able to show fractal patterns in the minute temperature differences throughout the whole of the cosmic microwave background. So we have fractals all the way up and all the way back. But going back to us, we find that the same fractal patterns that underpin, for example, complex systems such as ecosystems, is the same fractal patterns that underpin the nodes and the networking points of the internet. Yeah. We find, for example, moving beyond fractals. So let's look at power laws. Let's look at the incidence, for example, of earthquakes. We know that when we plot the incidence of earthquakes against their destructive power on a logarithmic scale, the Richter scale, that they form a straight line. So in other words, there's no such thing as an average earthquake. If you apply all the earthquakes, big to small, on that, that frequency and then logarithmic destruction, they form a straight line. It's called a power law, which says there's only one relationship for all of them, that an earthquake that is twice as powerful logarithmically is 4 times less frequent. That's it. So there's no such thing as an average. There's no Gaussian curve there. But at the end of the Second World War, a researcher called Lewis Richardson, and then subsequently to that, a researcher at Miami University, a gentleman whose surname is Johnson, but whose first name eludes me, looked at human conflicts at all scales and measured them in terms of their frequency against their destructive power in terms of human fatalities, and found the same relationship. Slightly different pitch, but nonetheless the same relationship as for earthquakes. Because what we're realizing, going back to what we're saying throughout this, is the appearance of our universe emerges from deeper levels of meaningfully information, and that applies to our human behaviors, our human consciousness, as well as universal consciousness and planetary sentience, that brings forward these same relationships at all scales. But the key here is, if we have the collective awareness to make choices of conflict, then we can evolve our collective awareness to make choices of peace. Mm-hmm. Mm-hmm. And this is, I think, one of the most fundamental conversations of our time, because this is what this new understanding and this, this unitive narrative that can, there's underpinned and framed by the evidence, but also can underpin and frame our choices and therefore our behaviors.
No, exactly. And that's why, when I labeled this podcast, I said that this podcast explores the nature of reality, consciousness, free will, but morality is a big part of it, because whatever belief you have regarding the nature of reality or consciousness will determine how you perceive your ethics, your morals, your values.
Everything.
Yeah. And with your view, I see such a deep, caring, healing nature towards it all. And I am definitely going to touch on these practical implications. But before we do, I just want to definitely make sure that we touch on as much of this, the science behind what you're talking about, because it's so amazing and it's so intriguing. One thing I did want to touch on before that was, there was the big breath. It all started slow out breath. You often talk about Vedic traditions and the Brahman and how they started this concept. What happens as we go along all the way to the end?
Well, the evidence we've got now is suggesting that it's a continued out breath. Mm-hmm. For a long time there was, is it going to be, is it going to do that, or is it going to bounce back, or what's going to happen? And we find that, the acceleration, very surprisingly for a lot of people, that the expansion of our universe began to accelerate again about 5 billion years ago. So it started with an acceleration, the first time, the first epoch of the big breath. It then slowed down because the balance of gravity and dark energy and all the rest of it. One out, one in. But then a space had expanded to the point of about 5 billion years ago. The acceleration began again. And it looks as though that there's no way in which that is likely to stop. And when I bring the third law of infodynamics into the piece, of course, the temperature continues to drop as the information continues to increase. You can see that there's a sort of a cycle here, because the temperature of our universe, as I said, began at the Planck scale at the first moment of the big breath, 10 to the 32 K. It's now down at just over 2.7 K. So we're looking to see that this life cycle, rather like a bubble, comes to a completion at some point. The other thing is there was some really good work done by, I think, Dennis Sobral a few years ago that I reference in the Cosmic Hologram, showing that the sort of epochs of stellar formation, and a big acceleration about 9 billion years ago, and then another, but progressively less and less, fewer and fewer, because the hydrogen to create new stars is being used up. So the view is that probably something like 98% of all stars that could form have already formed. Many of them have come to the end of their lives. And again, as I write in the story of Gaia, there's this incredible evolutionary arc, of massive stars at the beginning that formed black holes and supermassive black holes and galaxies. And then, it's just a beautiful, beautiful journey forward. So my perspective, again, with the evidence, I hopefully follow the evidence wherever it leads, but this is where it seems to be leading us, that our universe is finite in form. It's a great thought form, but a finite thought form in that sense, in the mind of the cosmos. And we're probably closer to the end than we are to the beginning in that regard.
And I mean, it does work. So a lot of people seem to, well, from what I've gathered, seem to think that you're talking about something completely different, but you're not. You're actually taking the current work we have and you're framing it in a different perspective. And I think that's important to note, is that it's not that you're making new claims in a sense. You're more just changing it and adjusting it in a way that completely shifts mindsets altogether. How do you feel this has impacted the scientific community? Because you know how scientists can be. I'm pretty sure you've been, because anytime someone talks about anything that goes outside of the status quo in science, you're labeled as so many different things. That how has it been on your receiving end?
It's been extraordinary, actually. It's been rather wonderful, because in a way, because as you say, I'm actually working with the evidence, and I'm working with the evidence of tens of thousands of researchers. I guess what I can bring is an ability to see patterns and an ability to join up the dots, because so many scientists are working at this incredibly depth of work, but they're not seeing what so-and-so is doing or so-and-so is doing in a different field of study. And what I can do, because of, my breadth of interests, is I can see the bigger picture of what it's all coming with and the direction of travel. And, also as a cosmologist, we're getting folks like Professor Brian Cox, who wrote a book with Jeff Forshaw last fall, basically on black holes, but coming at the end of that book to say more and more it's looking that the appearance of our universe is not its deeper reality. I don't know what that means, he says. But that's the point that cosmologists are coming to, because that is where the evidence is leading us. Now, you're right. I think, I'm also a student of the history of science. And I can see how certainly over the certainly until the 20th century, there was a perspective very much of this separation of science and spirituality. And I can absolutely, I've studied all the reasons for this and get it. But we're coming full circle or full spiral now, because the leading edge discoveries, and they really are only in the last few years, the holographic principle, the understanding of information. My redefinition of the laws of thermodynamics to infodynamics, it's simple. Anybody could have come up with that. The reason I did it is because I saw it with new eyes, as you say, and I wasn't caught with the old perspective. And so in that sense, and that's what Marcel Proust, of course, said, that the journey of discovery is not discovering new lands, it's seeing with new eyes. And so I think it almost is a situation where once somebody is willing to see with new eyes, it all fits into place. And it's not in any way dishonoring everything that's come before. We've needed to take every step, it seems to me. So I'm not into blame and shame on any way. But we do have a paradigm.
Yes.
That's actually not even 20th century science. It's 19th century science of a mechanical, mechanistic, materialistic, separatist universe. And that is being turned on its head. And when we bring consciousness in, it's not, how can I put it? It's for all faiths and none. It's human. It's who are we? It's remembering who are we? And not sort of making any labels or anything else. But this is where the evidence is inviting us to remember.
Jude, before I go on to the next portion where I'm going to talk about the practical implications as well as the Eastern philosophical aspects of how you came to your views at some point. The last thing I want to ask you is there anything you want to clarify in terms of the way you approach infodynamics, cosmic hologram, all of this, anything that you feel has always been misunderstood that you've been itching to kind of just get out there and let people know this is actually what I meant?
Not misunderstood, but I feel that there's still a misperception of people who work with entropy and seeing it as this order to disorder I was mentioning earlier, rather than as initially an increase in energetic microstates and now an increase in informational content, and now an increase in meaningful informational content, is this perspective that came through with people like David Bohm and Prigogione and others, realizing that in what's called a dissipative system, such as our planet and a person, that there seems to be a sort of a switch around of entropy. So entropy, it's not order to disorder, it's somehow disorders become order. And so what I've been able to share, and more people are now getting it, is it's the old concept or the misperceived concept of entropy as order to disorder, rather than from increased energetic states and now information. Because then what you realize in dissipative systems, let's talk about our planetary home, okay? A dissipative system, actually, energy comes in, energy flows through. What's not needed to support the homeostasis of that system is then dissipated, okay? If you think of that as information coming in, expressed as energy, information therefore used as a coherence to support the coherence of that system, and what is not utilized gets dissipated. So again, that then correlates with this perception both of the meaningful information, not just as underpinning, but the very stuff of that system, that throughput enables its coherence through its lifetime, whether it's a human lifetime or a planetary lifetime. But also it shows that then, going back to that third law, that temperature difference is a measure of the entropic potential. Yeah? Okay. So that in a planetary, if we have a planet where that dissipative process stops, the temperature difference between that planet and ambient space will reduce. Yeah. When we come to the end of our life cycle, our temperature, when we die, when our physical bodies die, our temperature then correlates with our ambience. So the ability, by maintaining a temperature difference in a dissipative system, is a measure of its continuing entropic potential.
I see. Okay.
Yeah.
Yeah, I get that.
And that's the one thing that I think people have quite a lot of, because terms like negentropy and syntropy and all sorts of stuff's come in. They're not needed. When you understand it in these terms, you can appreciate it's rather like the epicycles of medieval astronomy, pre-Copernican astronomy. You don't need it. And what you get is a much simpler understanding when you're seeing it with new eyes. So, the Copernican, putting Sol in the middle of our solar system, suddenly you don't need epicycles and all that complications, and you don't need the complications of negentropy and syntropy, which of themselves, violate this universal continuing increase in entropy.
I think it's very apparent. I mean, if you have a hammer, you look for nails, and science, I mean, it's very objective. So you're constantly looking from an objective standpoint. I mean, it's very difficult to step out of that. And I know I'm the same in that regard, because when I started this podcast, my views on consciousness were very fixed and firm. And the more it's gone on, the more it's continuously changed and non-stop. I mean, at this point, I question reality all the time, but it's something I've always done. But I mean, that fixed belief is no longer there. It's something that I'm open to exploring these new ideas. I don't think that the child in me would have explored concepts like this with so much just openness.
I love it.
And at this point, I mean, I love it.
Yeah, me too. I mean, it's all a work in progress. It's all a work in progress. I mean, for me, what's exciting is having had my first direct experience of multidimensional realities, noetic experiences from the age of 4. I've also, it's both and, I've also really, really, really valued, science as a process, as long as Francis Bacon, who is the father of the empirical method, follow the evidence wherever it leads. And I do feel he's been given quite a bad rap, which I would disagree with, because as a friend of mine, another friend of mine, Peter Dawkins, who's a wonderful Baconian scholar, he really has guided, like you've been, my guidance with this is that, 400 years ago, when Bacon in 1623, when they published De Augmentum Scientiarum, which was the beginning of the empirical method, Bacon's deeply philosophical perspectives, it seems to me, were that it wasn't going to peripheralize the divine, as he would have called it, but to reveal the divine through its empiricism. Because, of course, he was living in a time of Queen Elizabeth II and then James I of England, 6th of Scotland, where superstition, ruled the waves in that sense, and the church's authority. So it's almost come this full journey now, where leading edge science is revealing that universality and those wisdom teachings and the wholeness and the divinity within everything.
Exactly. And I think just to put it all together, because now as we reach the end, the end of this podcast, at least for now, maybe we'll do a round 2, but let's talk about, unity and non-locality is the basis of all of this. And at some point, it all comes together for us to understand and realize that everything is interconnected. There is no separation. This thought of separating things needs to slowly dissipate. And this does have practical implications. I think as we get into that, let's start from the Eastern philosophy that's inspired this and taken, because we've spoken a lot about Western science at this point, and I'm curious for you to apply the Eastern philosophy into how we should approach the practical and ethical implications moving forward with this theory.
Yeah, absolutely. Well, first of all, as you say, Tev, our worldview is our mindset, our narrative, our underpinning narrative is the way we see the world, and therefore the choices we make. And we've had a Western secular worldview of, as I say, based on 19th century science and all the structures that came from that, because in the 19th century, with that mechanistic, separatist, materialistic perspective, our structures became hierarchical. Whether it's our education, whether it's our organizations, our governance, our whatever. And now that's completely been turned on its head and converging much more with universal wisdom teachings and very much those of the Eastern traditions and the indigenous traditions. And so, for example, the Chinese I Ching talks about in the beginning is the one, not was, is. The one becomes two, the two becomes three, and from the three, 10,000 things are born. The yin yang symbol. We haven't even touched on the feminine, masculine, and all of that, but that's so important. But the yin yang symbol has, the yang with the yin coming out and the yin with the yang coming out. But the wave in that symbol is often not mentioned. But the wave is that creativity of what this all means. And I talk a lot about trinities, philosophically trinities, the masculine, the feminine, and the child. Yes. And in that resolution, and that's again seen through many, many traditions. We talk about the Vedic tradition, as we have before, Indra's net. The tradition talks of Indra's net as an analogy of a reality where every, reality made up of beautiful gems of many, many different colors and all different facets, and each facet reflecting others and linked by golden threads. Well, that is a millennia-old description, in my perspective, of the cosmic hologram.
In South Africa, because I'm Indian of Hindu origin and descent, but I was born and raised in South Africa, and the South African culture, there's this word, it's called Ubuntu.
Oh, I love that word. I love that
concept. I am because you are. Exactly. And I think that fits exactly with what you're saying.
Yeah, it's exactly that. And Ubuntu is so beautifully inviting in, because the other thing is that I love about Ubuntu, many things I love about Ubuntu, but I talk about, often we're now describing unity and diversity. But for a number of years now, I've said, let's take that a step further, beyond even unity in inclusion, to unity in belonging. Because what this is showing us that we all belong. And that is the very heart of Ubuntu.
Yes.
Ubuntu is so fundamental because you don't have to be invited into that relationship. You are inherently, fundamentally part of that relationship. And this is what we're discovering.
And so altogether, this unification, tell me about the overall goal for us as a society. How would you like this infodynamics and everything you've spoken about today to be applied somehow into it all?
Well, again, these things are have you ever heard of somebody called Mr. Magoo? He's very much in America. Yeah. And he always backs into things and then looks around and goes, oh, that's the story of my life, I think. So a couple of years ago, with all of this and writing the cosmic hologram at the time, and then the story of Gaia, writing the story of Gaia at the time, cosmic hologram would come out. I came together with a number of change makers and folks who'd been involved with United Nations for decades and involved with the Sustainable Development Goals and what's called Agenda 2030. And we're getting more and more frustrated because this realization that they were coming, not necessarily from the people who were trying to negotiate them, but certainly in the way they were articulated and then led out, very much from this siloed perspective. 17 goals and lots of measurements, but the goals themselves. And the realization from these 150 or so change makers that they could never be implemented with that sort of mindset. Einstein said, you can't solve a problem from the same mindset that created it. Well, we have a problem because of an illusion of separation, a dis-ease of separation. We cannot solve it from that same mindset. So all that I'm sharing and all that the evidence is pointing to is overturning that perspective and bringing in this realization and understanding of wholeness. So what these folks were really wanting to say is because they were coming from this perspective, how can we bring this perspective of wholeness into the SDGs and Agenda 2030? And one of the things that came forward was the need for a narrative that could share this. because we're a narrative species, we're a storytelling species. We've sat around, from the very beginning, sharing stories and sharing perspectives, who we are and what are we, who are we in the world, where do we come from, who are we, where are we going, and in that sense, making meaning of our existence. So we now have the evidence that is converging, the scientific evidence that's converging with universal wisdom teachings to offer us a unitive narrative, to underpin and frame us to be able to come together and serve potentiality for transformational change. So I got involved with this group of folks, and I put my hand up and volunteered. That's my mum. My mum always said, volunteer. You may not know what you're volunteering for, but volunteer. So I did, and I was one of the co-authors of a unitive narrative that these folks took on board and adopted, and the Evolutionary Leaders Circle, of whom I'm a member, also adopted, and others. But what that's now doing, that came forward just over a year ago. What that's done in the meantime is that late last year, the United Nations, for the first time in its 70-year history, adopted a group of NGOs and organizations founded on the unitive narrative, this unitive narrative. And so this unitive cluster now has a voice, has voices in all of the things that United Nations are doing. But that's just one thing, because the other thing it's now underpinning is bringing together folks who are really wanting to transform economics and finance system from a unitive perspective. Folks who are looking at regenerative economics, donut economics, living systems economics, but all of it underpinned and framed by a unitive narrative that then deepens it still further into unitive principles that serves the health, the whole being of our planetary home and our people. Unitive education. How do we share this story with folks of all ages and in so many different ways? And how do we share this in ways through arts and culture? Because this is what this is about. This is the many, many stories that can arise and be shared from this underpinning of a unitive narrative. So that's what I'm doing pretty much most of my time now, and sharing this understanding, but it's vital that it moves beyond understanding.
Yes.
It has to be experienced to be embodied.
Well, I hope this podcast helps to get that message out, Jude. I know you're time sensitive, and we've sort of reached the end of this conversation, but I just want to say thank you so much. And to quote, your work and obviously Ubuntu, I am a cosmic co-creator because you are a cosmic co-creator, and thank you so much for being part of this creation with me and a part of this experience.
Bless you, Tev. And it's folks like you. I've done so many podcasts now, and I'm in awe of each and every one of you as hosts, because your passion, your clarity, your service is so, so important, because the folks you will reach in their own way will, share this in their own way. We don't know where this ripples, but we know it does, because as you say, Ubuntu, we are inseparable. We are each unique and we are inseparable. And, this offers us authentic hope. This, I hope, empowers us and inspires us. And this, for me, seems that this is the invitation of the universe and our planetary home, Gaia. They're saying, come on, invite us to this adventure.
This has to be one of the most inspirational. Well, I'm feeling well inspired. One of the most inspirational talks I've had so far on this podcast. So thanks.
I'm liking it so far, because there may be others that are even more inspirational to come.
Yeah, no, I've enjoyed it tremendously. Thank you so much, Jude. I wish you all the best, and I'm looking forward to chatting to you again sometime.
I'd love that, Tev. Anytime. I'd love that.
So much. Take care, Jude, and we'll keep in touch. I'm looking forward to this airing. Cheers.
Thanks.